Hello, everyone.
Recording in progress.
Oh, all right. Okay. I hope everything is working because I just switched out my microphone. Well, all right. So, welcome everyone to Intro to Java. I will be your speaker today, and my name is Arky. So I'm a high school senior, and I actually graduated like 3 days ago. Um, I've taken APCS A in Java, but my main language is JavaScript. Please go easy, because I haven't really done anything with Java in like 2 years, and I also just got the slides to this like an hour ago, so this is gonna be great. Yeah, so Java originally got its name from a type of coffee in the Philippines, and it is now a programming language. So a special feature about Java is that it's object oriented, which means it allows like for the creation of classes and objects as well as subclasses. Java is considered to be a high level language, as opposed to a low level language like assembly or like Fortran. Um, Yeah, and its syntax is pretty similar to C, C sharp, and like all the C family things. Java is really useful because it is able to run on any operating system such as Mac, Windows, and Linux, and it uses JVM. There are a couple really common softwares that use or that are used for Java. The main one being Eclipse. I feel like a lot of AP computer science courses use Java and Eclipse, but Replit also supports Java as well. And there's also a ton of other IDEs, but those are some of the more famous ones. Java is useful in running the website backend, so like server side stuff. It can also be used to create Android apps in Android Studio, as well as games such as Minecraft. There are two types of files. When dealing with Java, there's the .java file, which is the uncompiled text or scripts, and then we have .class, which is the compiled version of those. So now we're gonna talk about some syntax and stuff. So, the basic when you run a Java file, the thing that actually gets executed is the main method, which is right here with the big red arrow. So the public static void main is kind of the first entry point into the into your Java program, and everything that's within these brackets is what is run. So here we have just a simple example of printing something out to the console, and that's using this long command here, system.out.println. And all it does is print hello and hi to the console. So the next fundamental thing to talk about with Java is the different data types. Java is extremely picky and specific about the data types you use for everything. So each variable that you define is assigned or needs to be assigned to a specific data type, and you cannot deviate from that data type. So here are 5 examples. So first we have the integer, which is just any whole number, either positive or negative. Then we also have doubles and floats in this middle bubble, and those have the capability to be to add decimals or become floating point numbers. So whereas ints or integers can only go like 1, 2, 3, 4, 5, you could have like 1.2 or like 2.4 or something in a double or a float. The Booleans on the right side of the screen is a simple true or a false. There are only 2 states, And Booleans are very useful for conditionals, which we'll talk about later. Two other data types are the character data type and the string data type. And these are usually meant for storing text data, such as the character A or the word hi. An interesting thing to note about the string data type is it's not actually a native data type like all these other ones. You can tell because the S is capitalized, which means it's using the string object from somewhere that's not necessarily native. All these other ones like int, double, and Boolean are native data types, however, so they're like built into the very base level of the Java language, as well as the character one. So each of these different data types have specific limitations. For example, ints, floats, longs, doubles, all of those have to be sorts of numbers. Like you can't put high into an integer or false into a float. They all have to be numbers. And each of these numbers has a different range of how far it can go. So the integer is can contain 32 bits of information. It's a little bit complicated to explain, but what it basically allows is you can store 2 to the 32nd power different values. So that is minus 2 billion or 2.1 billion all the way up to positive 2.1 billion. A long is quite a bit greater than that. You get 64 bits of information that you can store into a single number instead of just 32. So you can have a much higher order of magnitude number stored into this long. Floats or floating point numbers are pretty similar to integers in size. The only difference is that you're allowed to use decimals instead of just having a whole number. And similar thing with doubles, except it has the same amount of storage per se as a long and can also use decimals. Booleans, as we already went over, can only be true or false, and it's kind of just a binary on-off switch. And character is just any type of character. And usually people don't use byte or short at all, so I wouldn't really worry about those if I were you. So the next thing that I would like to talk about is variables. So as I mentioned earlier, variables all have to be created with a type in mind. So there are 2 steps to making a variable. First, we have to declare it, and this is the declaration statement here on the left, which is just int x semicolon. And here we're just like establishing what type of variable it is, and that is an int. Our second step is to initialize the variable by assigning it a value. So in this case, we have x equals 3 on the right-hand side. Fortunately, this can be simplified into just one statement where you can simply write out int x equals 3. So we can both declare and initialize at the same time. All right, so there are a couple different naming conventions for making variable names. So on the top, we have the snake case, where we kind of make a space between the words with an underscore, and it somewhat looks like a snake, not really, but that's just how it's called. And hence how it got the name snake case. The middle one we have is Camelcase. This one's a little bit clearer to how it was named. You basically just smash the 2 words that you want to combine together and put a capital letter on the first letter of the second word and each subsequent word. So you can kind of tell where each word starts within the variable name with Camelcase. And then finally, we have Pascal Case. And what that is, it's very similar to Camelcase, except you also capitalize the first letter of the whole variable name. Pascal case is usually used when creating classes, and we'll talk about classes in just a moment, or not like a moment, but eventually. All right, so a modifier for all variables is you can turn it into a constant by putting the word final in front of it. And what makes constants different than normal variables is that they just cannot be changed once they're initialized. So in this example where we have final int numlegs equals 4, we're never allowed to change that value again. So it's stuck being 4 the whole time. Oh yeah, and also another naming convention where you do all caps and the underscore is called screaming snake case. And I personally think that anyone who uses the screaming snake case is a psychopath, but it's up to you. So in Java, there are a wide variety of different operators that you can use, especially on the numbers, such as like ints and floats. So first we have the addition operator, which does exactly what you expect and adds the two numbers together. Same thing with subtraction, where you just subtract the number on the right side from the number on the left side. So 3 minus 2 equals 1. And then we also have the multiplication, which is just using a star, and it works as expected. But with the division comes a little bit of a quirk. So of course there are the standard cases, I guess, where the numbers will evenly divide. So in my example here, we have int x equals 4 divided by 2, and 4 divided by 2 is 2, and that's just the result for x. But if we change it slightly so that it's not an even denomination, so in this bottom example, we have int x equals 4 divided by 3. This is actually going to output 1 instead of 1 and 1/3. And that's because we have an integer, which means we can't have any decimals of any kind. So the computer just slices off that last little 1/3, and we're only left with 1. All the way to the right side, we can see that division would work as we would expect it if you use a double, which can handle decimals. So when x is a double and is assigned to 4 over 3, the value is 1.333, or 1 1/3, which is exactly what we would normally expect. One more operator is the percent sign, and what it does, and it's called modulo. And what it does is it simply takes the remainder of a division. So our top example, int x equals 4 mod 2, because 4 divided by 2 is cleanly 2 without any leftover, we could say there's 0 leftover and x is assigned to 0. With our example on the bottom, int y equals 11 mod 3, the result is 2 because the remainder of 11 divided by 3 is 2, because we get a 9 or there's 3 whole 3's, which gives 9, and then 11 minus 9 is 2, which is the leftover. There's a couple more functions. These ones, you must notice there is a math dot beforehand, and that just means it's using what's called a library, specifically the math library, in order to get those particular functions. So if we want to raise something as an exponent, we can use the math.pow function, and the number on the left-hand side inside the parentheses is the base, and the number on the right-hand side of the parentheses is the exponent. So math.pow of 4, 3 is the same as raising 4 to the 3rd power, which is 64. The ABS function, math.abs, is the absolute value. So if the number is already positive, it'll just leave it positive. But if the number is negative, then it will change it to positive. Next, we have the square root function. It does pretty much exactly what you expect. It'll just take the square root of whatever number's inside. And I don't really know how it responds to negative numbers, but it probably returns an error. Okay, next one. So we have math.max. It just compares two different numbers and returns whichever number is higher. So in this example, we got 5 and 10. So obviously 10 is greater, so that's what the function will return. And then we have random. Math.random generates a random decimal between 0 and 1. And you can use that however you want. Like you can multiply it to like, I don't know. It's math.random is just a pretty useful function overall. So, and on the very right, here's an example of using math.random in order to get a number between 0 and 100. Oh, and another interesting thing that's used in this last expression, we have int x equals parentheses int close parentheses, and then math.random times 101. So that first part with the int inside the parentheses is called an explicit cast. So a cast kind of forces the return of a different function into a certain type. So normally random would return a number between 0 and 1, which is a double. But by using the int cast, explicit cast on it, it forces that random number down into a whole integer number, I guess. And that allows it to match its type with the variable int x. Okay, next thing, we got Boolean statements. So Boolean statements can be either true or false, and there are a couple of operators that we can do on Booleans. So the first one we have is the OR operator, and it's made with two of the vertical bars. It's above, you hold shift and press the button above the enter key to get the vertical bar. And OR, if you guys know some probability rules, it's like you just add the probabilities of x and y. But in this particular case, it just checks if x or y is true, and it'll return true if either of those are the case. The AND operator is kind of the opposite. So use the ampersand twice. So we have x and y, and it'll only return true only if both of the things are true. So if x is true and y is true, then the whole statement would return true. But if either x or y were to be false, then the whole statement would return false. Another thing that I forgot to mention, or I forgot to put on the slides, is the exclamation point. So the exclamation point is a not operator. So it basically reverses trues and turns them into falses, and it also turns falses into trues. And now we're going to talk about conditionals, mainly the if statement. So an if statement, it'll run a piece of code if the conditional is true, and it'll skip that section of code if the statement is false. So here we have a little code snippet. So we have int x equals 3, and our first if statement is x greater than 3? The answer is no, so that particular statement will return false, and which means it will not print out yes. The second type of conditional is an else if statement. Actually, I'll talk about else first. So an else statement automatically runs if the if statement right before it returns false. So if we got rid of this middle block here, like just pretend this doesn't exist, we just have a simple if else statement. So the initial if statement does not fully run, or it does not run. So it continues on to the else statement and it runs that instead. And the third type of thing, is the else if statement. So the else if statement is kind of the same as putting an if statement like inside the brackets of an else. So it only runs if the first statement does not run and the conditional in the second statement is met, if that makes any sense. But yeah, those are if statements. All right, next we have for loops and while loops. They're pretty similar in every language. So in a for loop, you just define a variable, then you have a conditional and an incrementing statement. And what happens is the code between like these two brackets will run continuously until this condition up in the center is not met. But the incrementing statement would also be run in order to stop making this condition work. Okay, I'm sorry, this is a horrible explanation. But for example, in this code snippet, it would print out 3 x's. So like with the first run, we would have I equals 0, and then we check if I is less than 3, and that's a true statement, so it's going to run the loop and print an x. And after it prints the x, it's going to increment I by 1. So I is now 1, and which is still less than 3, so it'll print out another x, and then increment I again. So now I is 2, and 2 is still less than 3, so it'll print out a third x, and then increment I again. So now I is 3, which is not less than 3 anymore, so the loop will stop at that point. While loops are pretty similar in concept. It's just a little bit less rigid. So you can still have an integer labeled whatever you want, and you still have a conditional within this loop, and this condition will continue to run until it is not met. So this particular while loop is going to be printing out the value of I as it is incremented. So it's going to start out at 0, then increment I, then print out 1, and then increment I again, all the way up until I equals 5. And then when I equals 5, it'll terminate the loop because the condition inside is not met. All right, so arrays. Arrays are a method of holding multiple pieces of data within the same variable. So an example, here we have string of cars. So this means we're creating an array of strings. And within this string, we have within this array, we have a couple different strings. We have Volvo, BMW, Ford, and Mazda. So all of these are contained within this one string array variable. And this can be very useful for holding massive amounts of data, or not even massive, just multiple items of data. And you can recall any piece of the array using the square brackets. So this is called indexing. So we have cars, bracket 0, close bracket. So we're getting the index of 0 of the cars array. So the way indexing works is that the first item is assigned the index of 0, and the second item is assigned an index of 1, and it just keeps incrementing. So we would have index of 2 and index of 3 for this particular case. And recalling the particular item is just getting the index. Also, you can create an array that is empty with this particular syntax. So int empty array equals new int with brackets 10. So this creates an empty integer array of 10 items. And our next statement, we will get the index of 1, which should be empty. So empty array index 1, and then we assign that value 1, 2, 3, 4, 5. So now index 1 is now going to be assigned to this value. An interesting thing to note is that you're stuck to having only one data type in an array. So all of the values inside the int array have to be integers, and all the values within the string array have to be strings. And the biggest drawback to arrays, in my opinion, is that once the array size is set, you're not allowed to change it. So these arrays back here with sizes of 10 and sizes of 4, you can't do anything to add more values to that empty array, and there's no way to subtract them either. So it's just stuck at 10 different items, no matter if you want to use them or not. And the solution to that is array lists. So array lists are a little bit more flexible because they allow you to add and remove different items. So array lists are also locked to a specific type. As you can see here, they are. This is an array list of strings, and as you can see, we are adding the different cars or strings of cars to this array list, and then when you print it out, it still has all 4, just like with a normal array, except you are now allowed the flexibility to add and subtract more cars if you see fit. Now we're going to talk about methods / functions. So in Java, they call functions methods, and I think it's really weird, but it's okay. And methods have a couple different important parts. So the actual method is on the bottom half of this code snippet here. So we've got public static int find biggest, parenthesis int x, comma int y, and this whole line is the function declaration. And there are lots of important parts to this declaration. So we have public, which means you can access it in any class, regardless if it's in this same file or not. Static, which we'll talk about in just a moment. Int. So int here is the return type. So what the return type means is whatever this function or method returns has to be an integer. Then we have find biggest, which is just the name of the method. And every time you want to invoke or call the method, you simply type out its name and a set of parentheses. And inside those parentheses, you have to have a couple of parameters. So parameters are kind of similar to variables, except they're kind of scoped within the method and can't be used elsewhere. So it's like the method's own private set of variables. So, and just like variables, they require having a type and a name. So here we have int x and int y, meaning we have to give them integers. And anything between the two brackets is the body of the method, and you can just do whatever normal code stuff you do within that. In this particular case, it's very simple. We just check using an if statement if x is greater than y, and if it is, we'll return x because it is the biggest, and else, so if x is not greater than y, we'll return y instead. And these two return statements, return x and return y, are giving a return value to wherever or whoever called this find biggest method. So think of it like you're shipping this y out of the method into the print line statement, because this print line statement is then going to print whatever y was. So actually calling the function or calling the method, again, you first start by invoking its name and then have a set of parentheses. An interesting thing is that when you're calling the function, the stuff inside the parentheses is now called arguments as opposed to parameters. But for your arguments, you just need to make sure that the types match what is set at in the parameters. So 2 and 3 are both integers, so there shouldn't be any issue there. And then whenever it's called, the function is called, it runs through the body of the function, and you'll get your return value, which is then shipped out and used by the rest of the code. And in this case, it'll just be printing it. So there are 2 types of methods. There's static methods and dynamic methods. Static methods can be called without creating an object of a class. So objects are a little bit complicated, so I'll only talk about them briefly in the next slide. But basically what this means is that you can use static methods anywhere as like separate entities that aren't attached to anything else. And dynamic methods are kind of the opposite, where they refer to a specific object and its object variables. And I will also explain that a little bit more coming up. So in Java, you can create different classes, and from those classes, you can create objects. So in the student, here we have an example of a class. It's the student class, and inside of it, we have some variable definitions. I'll go over the public and private later. Then we have this middle section, and that is called a constructor. And then we have this third section, which is a dynamic method. So because we're just talking about methods, I'll go over this. So dynamic methods are kind of attached to the specific instance of an object. And to create an instance, you have to go inside your main, or not necessarily even main, just any other like class or place, I guess. And then you define what type it is, and your type is a student, which is the class that is up here. Your variable name, student1, and it is a new student, which is the student class, and you pass in your arguments. With this new instance, you're able to call the dynamic methods, which will return specific values that are special or specific to that particular student1 or particular instance. There are also these things called instance variables, and those are the things that are up here. So we have 2 types of instance variables. We got public ones and we got private ones. So a public instance variable means that you're allowed to retrieve it from outside of the class. So for example, if we want to print out the student's name, we just do print line student1.name, and then it'll print their name. But with private instance variables, you're not allowed to access it from a different class. So for example, if you try to do student1.favorite subject, you would get returned an error instead of getting your actual value. The way to kind of get around this is with setters and getters. It's kind of just a practice used by Java programmers in order to retrieve and change private variables without changing them directly. This last method right here, this dynamic method, is an example of a getter, because what it does is it just checks to see what the favorite subject is and it returns it. And as you can see here on the bottom line of the snippet, you have it will print math, which is this particular student's favorite subject. An interesting thing about Java is that there's no need to reinvent the wheel, and you're given a whole bunch of resources that you're allowed to just call, or that are just at your beck and call. And you can access these with the import statement. So import statements just import modules from other Java libraries and like other resources that are very useful. For example, the Arraylists, which we discussed earlier, come from a library which needs to be imported. Imports are, that is about it for imports. They're just helpful tools that you can use made by other people. So now, one last thing I would like to talk about is the different types of errors. So there are three main types. There's syntax errors, which occur if you're missing like a semicolon, or if you have like the wrong variable type. And those are generally, you get notified right away as soon as like you make them by whatever IDE you're using. The second type of error is a runtime error. Those unfortunately cannot be picked up immediately by your compiler or IDE, but when they pop up as the program's running, you will be notified. Some examples of this are divide by zero errors, as well as trying to index something from an array that doesn't exist. So those are examples of some runtime errors. And the last type are logic errors, where the program will run and compile and everything, but it doesn't do exactly what you want. So like if you have a typo and like accidentally put the wrong variable somewhere, that could lead to a logic error. Well, that's about it for Java. Thank you for attending.